The narrative unfolds with a reference to the movie Interstellar, wherein the main character, Cooper, escapes from a black hole, providing a poignant moment as he witnesses his daughter's final days. The discussion delves into the scientific aspects of the movie, raising questions about its potential inclusion in school curricula. Contrary to the fictional escape, scientific consensus has held that anything entering a black hole would likely be destroyed. However, a recent study challenges this belief, suggesting that destruction may not be inevitable. The discourse then reflects on the paradigm shifts in our understanding of the universe during the 20th century. Initially, the Milky Way was thought to encompass the entire cosmos, with a static and unchanging universe governed by Newton's law of universal gravitation. Einstein's general relativity replaced these notions, introducing the concept of an expanding universe and predicting the existence of black holes, which have since been observed and imaged. The narrative pivots to a speculative idea that contemplates the origin of our universe from a black hole. The notion proposes that the seed of a new universe could have formed within an extremely dense point just before the Big Bang, potentially inside a black hole. This idea challenges the conventional understanding that time began with the Big Bang, and the discussion touches upon unconventional perspectives suggesting a compressed, finite point as the seed. The focus then shifts to the characteristics of black holes, emphasizing their formation from the remnants of massive stars and the presence of a singularity at their center. The narrative introduces the concept of Hawking radiation, challenging the classical notion of black holes as completely black. This radiation leads to the gradual evaporation of black holes, creating a paradox concerning the loss of information. The video explores the challenges in reconciling determinism and the fate of information within black holes, delving into the concept of holography and its application to black hole physics. The discussion emphasizes the presence of an event horizon, a boundary beyond which objects are inexorably drawn toward the black hole center. The Schwarzschild radius is introduced, highlighting the mathematical indistinguishability of the inside and outside of a black hole. The narrative incorporates groundbreaking discoveries, such as the cosmic microwave background, CMB, suggesting the expanding and cooling nature of our universe. The discussion speculates on the possible connection between black holes, changes in the event horizon size, and cosmic inflation and dark energy. The video concludes by acknowledging the intriguing but speculative nature of these ideas, emphasizing the ongoing quest for evidence to confirm or reject these theoretical concepts.